So, this topic is about the atmospheric air pressure and winds. Basically, the atmospheric air pressure and winds refer to the force exerted by the weight of an air on the Earth's surface, while wind is the movement of air caused by pressure differences in the atmosphere. So, in introductions to the atmosphere is a gaseous envelope surrounding the Earth that support the life by providing the oxygen, protecting from harmful radiation, and regulating the temperature. So, what are the compositions of the atmosphere? Basically, the atmosphere consists mainly of the nitrogen, which is 78%, and oxygen, which is at 21%, with trace of the carbon dioxide, argon, water vapors, and other gases. So, layers of the atmosphere. The atmosphere have been divided into five layers. The first one is the troposphere, second one is the stratosphere, mesosphere, thermosphere, and exosphere, which is based on the temperature variation with the height. What is air pressure? Basically, we can define the air pressure is the force per unit area exerted by the atmosphere air due to the gravity, and it is commonly measured in pascals. So measures the air pressures in the barometer. For example, air pressure is measured using a barometer, which may be a mercury or aneroid types, and it's used in the weather forecasting. Variations of pressures with altitude. For example, air pressure decrease with increase in the altitude because air density become lower as the amount of overlying air decrease. High and low pressure zones, such as the high pressure zones, are areas of descending dense air and stable weather, where low pressure zones have rising air and are associated with clouds and rainfalls. How air pressure is measured? Air pressure is measured using a barometer, which is the mercury and aneroid. So, standard atmospheric pressure at sea level is 1013.25 heteropascals. So, change in the readings indicate that weather changes and are used in the forecasting. There is some factors which affecting the air pressure, such as the temperature is one of the factor which warm the air rises, creating the low pressure areas. Second one is the altitude, where the higher altitude having the lower pressure. And the third one is the humidity, in which the moist air is less dense, reducing the pressure. So now what is the role of the air pressure in weather system? For example, high pressure system usually bring clear and calm weather. Low pressure system associate with the clouds, winds and precipitations, while interactions of the systems, the movement and interactions of high and low pressure areas create the different weather phenomena. Now we define the winds. Basically, winds is the horizontal movement of the air from region of high pressure to region of low pressure near the earth surface. So how winds form? Pressure differences concept. For example, wind is formed due to the pressure gradient force created by unequal heating of the earth's surface, and it is influenced by the Coriolis force and surface friction. Global air circulation. Basically, global air circulations refer to the large scale movement of air through systems such as the Hadley, spherules, and polar cells, which redistribute heat across the earth. Now, the Coriolis effect. How we can define the Coriolis effect? The Coriolis effect is the deflect of movement air caused by the Earth's rotations. In the northern hemisphere, winds deflect to the right. In the southern hemisphere, winds deflect to the left. So this effect influences the rotation of the large weather system, such as cyclones and anticyclones. Global winds patterns, for example, trade winds, waterlies, polar easterlies, move air around the earth and help to distribute the heat and the moisture. It may be caused by the uneven heating of the Earth's surface, which is influenced by the Coriolis effect. Now, in the local winds, for example, sea breeze, where the cool air move from sea to land during the day, while in the case of the land breeze, cool air move from land to sea at the night. Valley breeze, for example, warm air rises up the mountain during the day, while the mountain breeze, for example, cool air flow down to the valleys at the night. So it is strongly influenced by the local geography and temperature differences that can significantly affect the local weather conditions. So winds flow around the pressure system. For example, in the northern hemisphere patterns, winds flow clockwise around high pressure system. So winds flow counterclockwise around the low pressure system. So this wind movements affect the local weather patterns and storm development. How winds move in the cyclone. For example, cyclone form around the low pressure centers. For example, winds spiral inward and upward due to the low pressure. The Carlos effect caused the spiraling patterns to differ in the northern and the southern hemisphere. So these cyclones can cause the severe weather, including the heavy rain and strong winds. So this may affect climate and weather pattern. For example, it influenced the erosions and the distributions of seeds and pollen that can cause the damage during the storms and hurricanes. So understanding the wind help in planning for the weather related hazards. Human use of wind energy. For example, wind turbines convert the wind energy into electricity. So wind farms are set up in areas with consistent wind pattern. So using the wind energy help to reduce the reliance on fossil fuels and promote the clean energy. So as a summary or the key concept, the atmosphere's compositions, layers and the properties like the air pressures are fundamentals to the weather. So winds results from pressure differences and is affected by the air earth rotation. So as a concluding remarks, importance of the air pressure and wind in the weather forecasting. So air pressure and patterns are essential for weather forecasting. So they play a vital role in agriculture, aviations and the daily life. Thank you so much.